This is part 1 video in graphing rational functions. A rational function is a function of the form p of x over q of x where q of x is not equal to 0. Domain of a rational function is all real numbers except the ones that make the denominator equal to 0. For example, for the function f of x equals x over x plus 3, all real numbers other than x equals negative 3 will be in the domain, because x equals negative 3 will make the denominator 0. It will make the function undefined, so we exclude that negative 3. Next example, x equals 6 will make the denominator 0, so we have to exclude that. If we were to write the domain in the interval notation, would be negative infinity to negative 3 union negative 3 to infinity. For second example, negative infinity to 6 union 6 to infinity. Next example, we don't want x to equal positive 1 or x to equal negative 4, because both of those numbers will make the denominator 0. So domain would be negative infinity to negative 4 union negative 4 to 1 union 1 to infinity. Tried problem, try the domain, try to find the domain of the given function. So to find the domain, we only need to worry about the denominator. We don't care for what's in the numerator. As we know, there's no radical function or logarithmic function involved in the numerator. So let's factor the denominator, two numbers, multiplying to give me 20, adding to give me positive 9. Factors are x plus 4, x plus 5. Now, two numbers that will make my denominator 0 are negative 4 and negative 5. Those are numbers that will be excluded from the domain. So domain in this case is negative infinity to negative 5, union negative 5 to negative 4, union negative 4 to infinity. Other than negative 5 and negative 4, every other number is allowed and is in the domain of this function. Rational functions and their graphs, discontinuous, a break in the graph or curve, break in the graph or curve. Point of discontinuity is wherever we have the break, that would be the point of discontinuity. We could have a hole in the graph, we could have a vertical asymptote, that would be point of discontinuity. Asymptote is the end, the line that graph of the function approaches but never touches or crosses. So asymptote is the point or the line the graph comes really, really close to, but it does not cross that line. Actually, that's not all true. Vertical asymptote, graph will never cross, but horizontal asymptote, your graph might cross. It may cross it, it may not cross it. If it does cross, it can cross it multiple times as well. So horizontal asymptote, your graph will or can cross. Vertical asymptote, your graph cannot touch or cross. Steps to graph a rational function. Step 1 is to arrange numerator and denominator in descending order and factor both numerator and denominator. Step 2, determine the domain of function. Exclude any values that make the denominator 0. Step 3, cancel the common factors between numerator and denominator. Any factors that gets cancelled will create a hole in the graph. To get the x coordinate of the hole, set the cancel factor equal to 0 and solve for x. Now plug this x value into simplified function to find the y coordinate of the hole. For rest of the steps, we're going to work with the reduced fraction from previous step. Find the vertical asymptote by plugging denominator equal to 0. Your graph will never cross a vertical asymptote. Instead, it will show a hugging behavior towards the asymptote. Next, find horizontal asymptote or slant asymptote. If degree of numerator is less than degree of denominator, horizontal asymptote is y equal to 0. If both numerator and denominator have same degree, then the horizontal asymptote will be equal to leading coefficient of numerator divided by leading coefficient of denominator. So if both degree of numerator is equal to degree of denominator, horizontal asymptote will be y is equal to leading coefficient over leading coefficient. If degree of numerator is greater than the degree of denominator, there's no horizontal asymptote, but there is a slant asymptote. How do we find the slant asymptote? By doing the long division. The quotient will be the slant asymptote when we do long division. Graph may cross the horizontal asymptote and slant asymptote, but it will never cross the vertical asymptote. Next, find the x and y intercept. Pick the test points around vertical asymptotes or make a table of values to complete the graph. Remember to label all the key points, list the domain and range of the graph. In the next video, we're going to see some actual examples of graphs of the functions, rational functions. In this video, we're just gonna look at finding some vertical asymptotes. Vertical asymptote is found by plugging the denominator equal to 0. Wherever your denominator becomes 0, that's where we will have a vertical asymptote. For example, for f of x equals x over x minus 3, the vertical asymptote will be x equals 3. So wherever your denominator becomes 0, that line is your vertical asymptote. Horizontal asymptote, if we have a bottom heavy polynomial, degree of denominator is higher than the degree of numerator, then horizontal asymptote will be y equal to 0. So there's 3 polynomials where degree of denominator is higher than degree of numerator. So for each of these, horizontal asymptote is y equal to 0. If degree of numerator and degree of denominator are equal, then horizontal asymptote will be y equals leading coefficient divided by leading coefficient. Leading coefficient of numerator divided by leading coefficient of denominator. So here are some examples. First example, both degrees are equal for numerator and denominator. So y equal to 1 is our horizontal asymptote. Second example, both degrees are equal, y equals 2, which is leading coefficient of numerator divided by leading coefficient of denominator is our horizontal asymptote. Same in the third example, leading coefficient of numerator divided by leading coefficient of denominator will be the horizontal asymptote. If we have a numerator heavy polynomial where numerator is higher degree than the denominator, in that case there will be no horizontal asymptote, but we will have a slant asymptote instead. In next video, we will see several examples of graphing rational functions.